We're given a function, and we're asked to find the x-intercepts and the behavior of the graph at those intercepts. So the first thing in order would be to factor this guy, and we see 1, 2, 3, 4 terms, so we're going to try factor by grouping. Out of the first group, we have a common factor of x squared, and it leaves behind x minus 1, because x squared times x is x cubed, x squared times negative 1 is negative x squared. And the second group, we pull out a common factor of negative 1, so just a negative sign will suffice, and then it leaves x minus 1. So we have this miracle common factor that will come out next. So pull that out in front, x minus 1 times what remains. When we strip it away from the first piece, it leaves x squared. Strip it away from the second piece, it leaves minus 1. Ah, okay, x squared minus 1 is the difference between two squares, so we can do better. We can use the formula here, the formula that says a squared minus b squared equals a plus b times a minus b. That's the formula we're going to use here for a squared, x squared minus 1 squared. 1 squared is the same as 1. So we have x minus 1 times x plus 1 times x minus 1. Well, look at that. We have repeated factors. We have x minus 1 raised to the second power times x plus 1. So what you do is you factor, and after you factor, see if you can write any of the factors in exponential form. All right, so we're ready now to establish our x-intercepts. We do that by setting y equal to 0, which is the f of x. And we're factored already, so that means we use a zero product property and set each of our factors equal to 0. X minus 1 squared is going to equal 0, and that's going to give us x minus 1 equals 0. So x will be equal to positive 1. And then we have x plus 1 equals 0. And then we solve for x. We get x equals negative 1. Now, this is our first x-intercept, the ordered pair. X is 1 when y is 0, and the multiplicity is the exponent on the factor containing this root x equal 1. Now, since our multiplicity is even, that means that we have a situation where the x-intercept, where the graph is going to actually cross at the it's going to kiss at the x-intercept. So, pointing out even multiplicity, that's the reason why we say that this x-intercept is going to be a kiss. It's just going to touch the axis and then turn around. Now let's do a similar analysis for the other x-intercept. This gives us the ordered pair negative 1, 0 for an x-intercept, and we'll see that the power on the factor containing negative 1 is x minus a minus 1. It's this guy here, and he has the invisible power 1. What that means is an odd multiplicity. And odd multiplicity implies that the x-intercept will be a cross. It'll cross over the axis instead of kissing it. Even multiplicity is a crossing. Kiss, and odd multiplicity is a crossing.